Welcome to Unit 3, which is solving absolute values, or absolute value. 3a is solving absolute value equations. So the directions for each one of these is to solve for each variable. Let's get right into it. Number 1 here, we have the absolute value of x equals 3. If you can remember back from Algebra 1 or middle school, every absolute value equation has two solutions. You have first solution is you just drop the absolute value, and the second solution is multiplying the right side of the equation by -1. So for both solutions in this case, you have 3 and -3. On to number 2. So the very first thing here would be to write two equations down, both equations. They're exactly the same. Only difference is multiply the right side of the equation by -1. So by doing this, now I solve both equations. You have multiply by 3, n equals 6. That's one of my solutions. And we have n over 3 equals -2. Multiply by 3, n is going to equal -6. Probably seen a pattern that if you have 6, -6, 3, -3, this pattern doesn't always happen. First thing you need to do, though, so that pattern just doesn't work. For number 3 here, we have a little extra. If you notice that number 1 and number 2, the absolute value was all by itself. There was nothing on that side of it, nothing on the outside. You had to subtract, multiply, divide, nothing on the outside of it. But on number 3, we have this divide by 8. We have to isolate the absolute values first. So we have to get this absolute value isolated first. You get that by itself. So what we need to do is divide by 8, so you multiply by 8, the opposite. This moves the 8 to the other side of the equation. Now, the absolute value is isolated on one side of the equation. So this is where we're going to break up the equation into two different parts. So you have 7p plus 4 equals 24 as one equation we're going to solve. And then we have 7p plus 4 equals, and multiply the right side by -1. Now let's solve both problems. Subtract 4, 7p equals 20, divided by 7. We get p to equal 20 over 7. On the right side here, if we subtract 4, this is where we're going to get a different answer. Same, -28, divided by 7. We get p to equal, this is -4. Moving on. Number 4. We have -2 minus 5 times the absolute value of 5m minus 5. We have a subtraction on the outside and a multiplication. Remember order of operations, so we do the reverse order of that. So we have subtraction and multiplication. If we're subtracting, that tells us that we're going to have to do something with that first. Well, we don't actually do something with subtraction. The 2 is a positive 2, so we're going to subtract 2. So the very first thing we're doing here is we're getting this absolute value isolated. So this absolute value's got to get all by itself on one side of the equal sign. Again, let's divide by -5. 15. Now the absolute value is isolated. So now we can break this up into two different problems. We have 5m minus 5 equals 15. And 5m minus 5. So write down the absolute value exactly the same. Just multiply the right side by -1. Solve both of these equations. Add first. Then divide. In this case, equal 4, and times going to equal -2. Both are solutions. Moving on. All right, now we have absolute value on both sides of the equation. Well, this is already isolated, so we can move on to the second step. You say, Mr. Johnson, what's the second step? Well, you're still going to write two equations. First one's exactly why you see it. Don't multiply anything by negatives. Second equation, you're going to multiply everything on the right side. It really doesn't matter which side, but I always say right side by -1. So let's solve these. Yeah. I don't like fractions, so I'm going to get rid of the fractions right away. So I'm going to multiply everything by 3. By doing this, we'll get z -6 equals 27z minus 18. Now I've got rid of the fractions. Now I can get like terms together. Subtract z, add 18. 12 equals 26z, and divide by 26. Z equals 6/13. And then over here, I'm going to distribute the -1 in first. So 1/3 z minus 2 equals -9z plus 6. And multiply by 3. I'm going to get rid of all the fractions always. Not a huge fan of fractions when solving equations, so I get rid of them. And let's get like terms together. So it's -27, so I like positive numbers, so I'm going to move that over and move the 6 to the right side. So we have 24 on the right side and 28z on the left. Divide by 28. And z is going to equal 24 28 is 12/14, which is 6/7. Okay, there is a certain thing that if you end up with, when you get an absolute value, so this is a special case. If you ever get something that's like absolute value equals a negative number, absolute value always comes out positive, so you can never equal a negative. So in this case, it would become a no solution. So a quick example, if you get 2 plus parentheses x plus 5 equals -10, subtract 2. So once you get the absolute value isolated, if it's going to equal a negative number, so it equals a -12, there's no way an absolute value can equal a negative number, so there's no solution. Moving on. 3b is solve absolute value equations to inequalities algebraically. So we already took care of the equation, so we just want inequalities. So this is really very, very similar. You're going to isolate the absolute value first. Divide by 2. Once the absolute value is isolated, and b must have come up. You're going to break it up into two equations. First equation, write it down exactly how you see it without absolute value. The second equation, multiply the right side by -1. Now, when you multiply the right side by -1, the inequality switches. It was greater than here, becomes less than by -1. So anytime you multiply or divide with inequalities, multiply or divide, you switch the inequality. So solve these quick. divided by a positive number, so the inequality does not switch. Let b is greater than 3. Less than negative 44. Divided by 10. B is less than negative 22 over 5. Okay, moving on. So here we have same thing, isolate. So you're going to be doing a lot of computational math. Divided by 9, divided by a positive number, so the inequality does not switch. But in this case, when you isolate, so the absolute value is isolated here. At this point, take a look at it. The absolute value of anything is always going to be a positive number. There's no way a positive number can be less than a negative. So in this case, if you did no solution. There are some special cases for this, for inequalities. So if the absolute value of something is less than a negative number, that's a no solution, just like if it was equal to. And if the absolute value of anything is greater than a negative number, remember absolute value, anything that comes out of absolute value is positive. So a positive number is always greater than a negative. So this would be infinite solutions. And that will conclude your 3B. Come to class with any questions, and you'll have a warm-up on one of the examples.